The structure of most compounds is relatively easy to determine based on the chemical formula. However, when you are dealing with organic compounds, it is often beneficial to actually sketch out the structure. This is because organic compounds can have a variety of different arrangements of their atoms. Remember that in chemistry, organic refers to nearly every chemical that contains carbon. To illustrate what I mean, let's consider the empirical formula C2H6O. By definition, an empirical formula simply gives you the ratios of each element in a compound. It does not tell you the actual amount of each atom or how the atoms are arranged. For example, C2H6O could refer to C2H6O or C4H12O2 or C6H18O3, etc., etc. Let's just look at two different ways we can arrange 2 carbons, 6 hydrogens, and 1 oxygen. The first one is ethyl alcohol. Let's bring in 2 carbons. Carbon atoms will form 4 bonds to other atoms. In ethyl alcohol, the carbons are bonded to each other, and 1 carbon is bonded to 3 hydrogens, while the other is bonded to 2 hydrogens. Hydrogen atoms can only form 1 bond. This carbon will bond to oxygen. Oxygen atoms can form 2 bonds. This means oxygen will form a bond with the remaining hydrogen. This is the structural formula for ethyl alcohol. Another way to write this is CH3CH2OH. Hopefully you can see how this sort of breaks the compound into segments. Writing the chemical formula this way gives you more information about the compound compared to writing C2H6O. Now let's look at a different structure for C2H6O, ether. This time we will sandwich the oxygen between 2 carbons. We will complete each carbon's bonds by filling in the 6 hydrogens. Breaking this compound into segments would give us CH3O, CH3. So there you go. 2 different ways to draw a compound with the chemical formula C2H6O. Of course, we have some vocab for this. Compounds that have the same chemical formula but different structural formulas are called isomers. Ethyl alcohol and ether are isomers of each other. Of course, it is time for you to try one. 2 of the 3 molecules shown here are isomers of each other. Start by determining the empirical formulas. In other words, count up the carbons, hydrogens, and oxygens and write the number of atoms in the appropriate blank. Then circle the 2 structural formulas that represent isomers of each other. Pause the video and give it a try. Press play again when you think you have it. Organic compounds often form cyclical or ring structures, and one of the most common of these is a benzene ring. The plastic in your pop or Gatorade bottle contains a benzene ring. So does the plastic you know as styrofoam. These are the 2 chemical shorthands for benzene rings. Here is what C6H6 really looks like, however. There is a carbon at every corner of the hexagon. Now remember that each carbon has to form 4 bonds. Right now, each carbon is only shown with 3 bonds. 1 double bond to another carbon and 1 single bond to another carbon. The 4th bond is to hydrogen. One thing that you will learn as we go through class is that chemists are lazy. They find shortcuts for everything. Drawing a bunch of hydrogens is hard work. So why do it, right? If 1 or more of the carbon's bonds are not shown, then they go to hydrogen. So each carbon in a benzene ring shows only 3 bonds. The 4th is to hydrogen. See this hexagon with a circle inside of it? That's just chemists being lazy again. Instead of drawing the alternating double bonds inside the benzene ring, they simply draw a circle inside of it. The structure is the same: 6 carbon atoms and 6 hydrogen atoms. So, as I have mentioned several times, carbon atoms must form 4 bonds. A carbon atom could form 4 single bonds, 2 single bonds and 1 double bond, or 1 triple bond and 1 single bond. Hydrogen atoms can only form 1 bond. They will single bond to everything. Hydrogen atoms never form double or triple bonds. Oxygen atoms will form 2 bonds, so they can form 2 single bonds or 1 double bond. Nitrogen is an atom we haven't talked about yet. Nitrogen atoms will form 3 bonds, so they can form 3 single bonds, 1 single bond and 1 double bond, or 1 triple bond. Keep these facts in mind as we work through several examples. Let's determine the chemical formula for molecules containing cyclic structures. The first 2 here, aspirin and adrenaline, both contain benzene rings. I'll help with aspirin. Start by filling in the missing carbons. Put a carbon at every corner in the ring. Stopping here is the biggest mistake that students make. We have to check that every carbon atom has made 4 bonds. Look at the carbon here at the top of the benzene ring. It only has 1, 2, 3 bonds. A 4th must be drawn to hydrogen. Same thing here with these 3 carbons. Each one only has 1, 2, 3 bonds shown. We must draw in the necessary hydrogens. Check out these 2 carbons. Both of them have 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. So now we are ready to just count up the atoms and determine the chemical formula. 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And 1, 2, 3, 4 oxygens. C9H8O4. Your turn. Pause the video and follow the same procedure to determine the chemical formula for adrenaline. When you think you have it, press play to check your work. DDT is a large molecule with 2 benzene rings. Let's fill in these carbons. How many hydrogens do we need to fill in on this benzene ring? 4 is the correct answer. Fill carbons in here. How about now? How many hydrogen atoms does this benzene ring need? 4 again. Counting up all the atoms would give you C14, H9, Cl5. Caffeine is a different beast. Notice there are no benzene rings. Also notice that some of the positions in the rings are occupied by nitrogen. No big deal. The same rules still apply. Put a carbon atom at every corner of the ring where there isn't a nitrogen. Now, carefully check that each carbon has 4 bonds. How many hydrogens do we need to add? Only 1. These other carbon atoms each have 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. The formula for caffeine is C8 H10, and 4, O2. You know what's going to happen now. Pause the video and determine the chemical formulas for Novocaine and dioxin on your own. Fill in the carbons and then make sure each carbon has 4 bonds. Add hydrogen atoms to those carbon atoms that do not have 4 bonds. Be careful with dioxin. Those aren't benzene rings. Push play when you are ready to check your work. That dioxin was tricky. Notice there are several carbons with only 2 bonds shown. That means you needed to draw in 2 bonds to hydrogen. If you got dioxin correct, you can handle any formula that gets thrown at you. Nice work.